Hello, my name is Victoria.
I'm Akash.
And I'm Joanne, and we research the chemistry of pseudoephedrine. Pseudoephedrine is a pharmaceutical that relieves stuffy noses and sinuses. It relieves seasonal allergies and the common cold. While pseudoephedrine is effective in relieving symptoms, it doesn't treat or speed the recovery of health conditions. Pseudoephedrine is commonly used and found in many common medicines, such as Advil, Sudafed, and Claritin. It is a leading active ingredient in cold, allergy, and sinus medicines.
Alright, so here I'll be drawing the pseudoephedrine molecule. So it starts out with a benzene ring. And there's a double bond here, double bond here, double bond there. And it's connected, a couple carbons come off of it. This is an OH group. And off of here is a methyl group. And then there's another methyl group. So this is pseudoephedrine. And there are two chiral carbons in this molecule, so these are the two locations of it. And a generic drug that's similar to pseudoephedrine that has the same properties is phenylephrine. It starts out with the same benzene ring. So there's double bond, another double bond, another double bond. And the majority of the structure is kind of similar, so there's a methyl group right here. OH. So it's very similar to the structure of pseudoephedrine, but the difference is there's an OH coming off of the benzene ring. And this is phenylephrine.
An example of pseudoephedrine is Sudafed, which have pseudoephedrine hydrochloride tablets. The HCl makes it a salt, allowing us to take it as pills. So Sudafed is a nasal decongestant. In a broad sense, how it works is that it constricts the blood vessels in your nasal passages, which are the channels for airflow through your nose. In addition, the sinuses drain. So overall, your nasal passages and sinuses clear so that you can breathe more easily. Before we go into the specifics of how pseudoephedrine works, we need to understand some terms. The first one is agonist, which is a chemical that binds to a receptor and activates the receptor to produce a biological response. The second term is antagonist, which blocks the action of the agonist. It is a chemical that blocks a biological response by binding to and blocking the receptor. The last term is adrenergic receptors, which are protein-coupled receptors that are targets of norepinephrine and epinephrine, otherwise known as noradrenaline and adrenaline. With pseudoephedrine, we focus on two adrenergic receptors, the alpha receptor, which is the primary receptor, and the beta receptor, which is acted upon on a lesser degree. Here's a video to show the specifics of how pseudoephedrine works in our body.
Pseudoephedrine acts by binding to two receptors called alpha and beta-2 adrenergic receptors that are found in different types of muscle cells. Muscle cells that line blood vessel walls contain alpha adrenergic receptors. When pseudoephedrine binds to the receptors, the activated receptors cause the muscles to contract, and in turn causing the blood vessels to constrict. These constricted blood vessels allow less fluid to flow from the blood vessels into the nose, throat, and sinus linings. This leads to reduction in inflammation of the nasal membranes and production of mucus. Beta-2 adrenergic receptors, on the other hand, are found on cells in the smooth muscle of the bronchi, which are the main air passages that connect the trachea to the lungs. When pseudoephedrine activates beta-2 adrenergic receptors, it relaxes the muscles, thereby leading to dilation of bronchi. This leads to reduction in congestion and improvement in breathing. Therefore, the impact of pseudoephedrine on the two types of muscle cells resulting in contraction of sinus blood vessels and relaxation of the bronchial passages combine to make it an effective medication for relief of cold and allergy symptoms.
So pseudoephedrine acts on the alpha and beta adrenergic receptors that we talked about. So the alpha receptors, those are sites on the cells that control vasoconstriction, which is the constriction of your arteries and veins, intestinal relaxation and pupil dilation, and beta, which is like the lesser active site of pseudoephedrine, controls heartbeat, heart contractibility, vasodilation, smooth muscle inhibition. So when the alpha receptor is activated, the blood vessels are constricted, and this in turn increases the blood pressure. But since this occurs in the mucous membranes of the respiratory tract, the medication shrinks the swollen mucous membranes and in turn reduces congestion. The side effects of pseudoephedrine are restlessness, nausea, vomiting, weakness, and headache. Some of the rarer ones are nervousness, dizziness, difficulty sleeping, stomach pain, and irregular heartbeat.
Unfortunately, pseudoephedrine has been abused because of its stimulant effects. It increases heart rate and blood pressure, giving an excitable, hyperactive feeling. Pseudoephedrine has been used to illegally create meth.
You're going to come in and buy some Sudafed for your husband. You go home and both of you get sick, and so you both take it. Well, then you come back in a day or two later because you both went through that box and you want to buy another box. Unfortunately, even though you're just a normal person, I can't sell you another box.
It used to be available over the counter without prescriptions, but now there are limits to how much a customer can buy, to 7.5 grams per customer per 30-day period, and they are sold behind the counter to keep track of purchases. Because of this, many drugs have replaced pseudoephedrine with phenylephrine, which can be bought over the counter in any quantity. The structure of phenylephrine makes it impossible to convert it into methamphetamine.
Pseudoephedrine has a similar structure to another molecule called methamphetamine. So methamphetamine has a benzene ring, just like pseudoephedrine, with 3 double bonds. And there's a hydrogen coming off of each part of the pseudoephedrine, but you don't really have to draw it. So these are the carbons. This is the hydrogen. So the main difference is that the OH group from the top has changed to a hydrogen. The rest of the structure is fairly the same, fairly similar. So this is the OH group, it's changed to an H group. And this is methamphetamine. The name for this compound is 1-phenyl 2-aminopropane. So phenylephrine, on the other hand, cannot be converted as easily to methamphetamine. When you try converting it to methamphetamine, this is what happens. There's an OH group on phenylephrine that is different from pseudoephedrine. So it comes off the benzene ring, and when you try converting it to methamphetamine, it doesn't convert. So the rest of the structure is the same, but this one OH group coming off of the benzene changes the properties of the molecule. This OH group stays on. So it's different from methamphetamine, and it's not even called methamphetamine. This is the name.
Here's a graph that compares the years between 1998 and 2008 versus the number of methamphetamine labs confiscated. In 2005, a law was passed restricting the purchase of pseudoephedrine. Consequently, because pseudoephedrine was very often used to produce meth, we see a sharp drop in 2005.
Meth has been particularly easy to get because to find it, you don't have to go too far. What many consider the world's most dangerous drug can be cooked up at home from common cold medicine.
Because of the similarity between chemical structures of pseudoephedrine and methamphetamine, the pharmaceutical is often illegally used to create meth. In terms of mass production, it is relatively simple to create extremely large amounts of methamphetamine from pseudoephedrine tablets. A 2-day process that involves separating the pseudoephedrine from the salt tablets, mixing the pseudoephedrine with red phosphorus and hydriodic acid, neutralizing the acid with a lye solution, and making the solution a crystalline salt using HCl gas can result in hundreds and thousands of methamphetamine doses. Another quicker and simpler method, called the shake and bake method, is used by many amateurs to create small amounts of meth by mixing a few handfuls of pseudoephedrine tablets with household chemicals in a bottle. Since it is so easy to produce methamphetamine from pseudoephedrine tablets, legislation has since been passed restricting the purchasing of mass amounts of this pharmaceutical. Many pharmacies are also beginning to replace pseudoephedrine with phenylephrine in their drugs. Because of its similarity in structure to adrenaline, which naturally binds to adrenergic receptors in the body, pseudoephedrine can bind to alpha and beta adrenergic receptors. This allows the medicine to work, reducing congestion. The structure, however, is also similar to that of methamphetamines. Due to this, the drug is often abused to create meth. Thus, as of 2005, regulations are in place to restrict purchasing mass amounts of the pharmaceutical. All in all, pseudoephedrine is an effective nasal decongestant, important not only because of its intended functions, but also because of its chemical structure that makes it possible for illegal use.